Let's talk about geometry and let's start talking about lines, angles, and on top of it, triangles. We need to go over a lot of terms that you're going to run into during the SAT on the questions, and we are going to go over some type of question that you can have on your exam. So, first of all, finally, with these topics, we are going to use this reference. This is the only reference you have during your SAT exam. Those are all formulas to find the areas of each figures or the volume of each 3D figures, okay? Then it provides you some other information, such as the fact that the number of degrees of arc in a circle is 360 degrees. I hope you know that. And the number of radians of arc of a circle is 2 pi. That we're going to talk about during when we talk about the circle. The important part about what we're going to talk now is the fact that the sum of the measure of the degree of the angle of a triangle is 180 degrees. So we're going to go over this soon. Most importantly, we see here two triangles. Those are called special right triangles. These are going to be keys to solve many geometrical questions, especially when we talk about triangles, but also when we talk about trigonometry in a future video, and circles. So let's start talking about geometry, and let's start with some nomenclature. A line is a straight arrangement of points. So this is a line. Characteristic of a line that doesn't have a begin or an end. A line that is a begin or an end is called a segment. The line here, PQ, is actually called segment. Array is a part of a line, meaning there's an end point, but not a begin point. Another nomenclature that we can run into is midpoint, which is just the point in the middle of any figure or line, like in this case, and segment bisector or bisect. Bisect is whatever line we use to split a figure in two exact parts, like in this case. There are many questions there we already saw before. Topics get mixed. This is one of them. This is a question regarding a segment, but clearly, for the way the question is structured, we can solve it by using algebra. So here we have this figure, and the figure say, in the figure above, AB, so this segment, is equal to 2/3 of BC, so this segment. What is the length of AC? So the entire segment. In this case, we can use this information provided to write an equation. Why? Because we know that AB is going to be x plus 3. The length of AB is going to be x plus 3. And this one will be equal to 2/3 of 3x minus 6. So now we have an equation, we just need to solve for x. So what we're going to do, we are going to simplify the right side by doing this multiplication by distribution, which will be 2x minus 6 divided by 3 is 2 by 2, 4. And now we solve for x. So I'll move the x in this side, 4 in this side, and I'll have that x, because 2x minus x, is going to be equal to 7. That means now that my section AB is going to be 7 plus 3, which is just 10. And my section BC will be just be 3, then multiply 7 minus 6. 3 by 7 is 21, minus 6 is 15. So AC, that is just equal AB plus BC, it will be just 10 plus 15, which means that AC will be 25. There is no unit involved, so the answer is just 25. Let's talk about angles. Nomenclature about angles in English. An angle is called acute when this measurement is between 0 and 90 degrees. this angle QOP, for example, is an acute angle, or QOR. Notice that the angle in the middle, the one formed by the two lines, is always in the middle also when it's written down. This is indicate this angle POQ. Let's moving on. Right angles are any angles of 90 degrees. The angle ROS is a 90-degree angle. Whenever we deal with 90-degree angles, sometimes the question doesn't tell you right away, but it gives you this little square. This little square right there at the central angle is telling you that it's a 90-degree angle. It's a right angle. An obtuse angle is any angle between 90 degrees and 180 degrees. So the angle QOS in this case is an obtuse angle because it's more than 90 but less than 180. A straight angle like POS is an angle of 180 degrees. We need to also know about supplementary and complementary angles. Two angles that sum together gives you an angle of 90 degrees are called complementary angles. So the angle A plus the angle B would give you an angle of 90 degrees. That means that those angles are called complementary angles. Two angles that sum together give you an angle of 180 degrees that are called supplementary angles. Okay, and here it's something regarding angle bisector, pretty intuitive. I'm gonna go over it right now. However, I want to talk about special pairs of angles and all angles that are similar. I would say like that. In fact, if we have two lines that cross each other, they will form four angles. These four angles are gonna have some similarity. In fact, the angles that are in front of each other are going to be the same. So in this case, the measurement of angle 1 must be equal to the measurement of angle 3, as well as 2 must be equal to angle 4. Because of this, we can come up with other similar angles. In fact, if we have two parallel lines L and M, and then a transversal line T, we are going to have many similar angles. For example, the angle Q and the angle 4 are going to be the same. Why? Because of the spatial pair of angle that we saw before. For the same reason, angle 1 and angle 3. However, because of the corresponding angle right here, we also know that angle 1 and angle 5 are going to be the same, as well as angle 3 and angle 7, as well as angle 4 with angle 8, as well as angle 3 with angle 7. I already said that. Angle 2 with angle 6. And that's not the only type of similarity I can find, because I can go over the alternate interior angles that say that the alternate interior angle are going to be the same. So in this case, angle 4 and angle 6 are the same as well, angle 3 and angle 5. We can even go over alternate exterior angle, which say that angle 1 is going to be equal to angle 7, but you already saw that. Angle 2 and angle 8 are going to be the same as well. So in a situation where many lines cross each other, you can find many similarities. How to identify them? You need to remember the special pair of angles and these three boys: corresponding angles, alternate interior angles, and alternate exterior angles. And I want to close this by talking about consecutive same side interior angles, which basically are all the angle right here, internal from the two parallel lines. In fact, these angles have the characteristic that their sum, so 4 plus 5, will always give you 180 degree, as well as 3 and 6 is going to give you 180 degree angle. So that means that these angles are called supplementary angles we were talking before. Okay. That's a little bit of repetition of what we just said. So let's see this two type of problem. Problem number 4 says, in the figure above, line L is parallel to line M. What is the value of X? We want to find this angle, right? And the only information we actually have is that this angle is 55 degrees. Because of the alternate interior angle, I noticed that this 55 degree angle corresponds to this angle as well. These two angles are the same, so also that angle is 55 degrees. Also, as I mentioned at the very beginning, whenever we see a little square like this one, that indicates that that angle is going to be a 90 degree angle. Notice also that all these segments between those two parallel lines are making a triangle, right? Now, I don't know anything about this triangle, but I know that this angle is 55, this angle is 90, and the sum of the interior angle of a triangle is always 180 degrees. So I will find 180 degrees by doing what? The 90 degree, the sum of the 90 degree angle plus 55 degree angle, this one in golden, plus X. So now what I can do is just solving this that looks like an equation for X. And I will end up that X is equal 180 minus 90, 90 minus 55, 35 degrees. So my right answer will be B. Let's take a look at question number 12 from preparation test. In the figure above, line P is parallel to line Q. Again, two parallel lines. Which of the following must be true? So now we have three statements. Let's analyze each of them. Statement number 1 says that the measurement of angle Q must be equal to the measurement of angle 9. This statement is true for this principle, corresponding angle. Because of corresponding angle, angle 2 and angle 9 must be the same. Okay? Statement number 2 says that angle, so this one, first of all, statement number 1 is correct, perfect. Statement number 2 says that the measurement of angle Q plus the measurement of angle 4 is 180 degrees. This statement is false because two angles are supplementary angle when their sum is 180 degrees, but in this case, the two angles that will make 180 degrees are 2 and 8, or 4 and this one that we don't know, it doesn't have a number. So the measurement will be on the vertical corresponding angle, not horizontal like in this case. So this statement is false. Now the most interesting statement is statement number 3. Statement number 3 say that summing angle 4 plus angle 8, we would get angle 5. This statement is true, and I want to show you why. Let's make now another line that is also parallel to P and Q. Let's call it M. Make a hole here to see angle 5, 1 second. However, now that I formed this new line, I form also many other similar angles. In fact, angle number 8 originally was the same as this angle right here. For the same principle, angle number 8 must be equal to this angle right here. Same proceeding is with angle number 4, because angle number 4 for the same theorem on angle number 8, which is the alternate interior angle, must be equal to angle number 6. So when I draw the line M, this angle corresponds also to this angle. For all this principle, my statement is true. Let me fix something. I did a little mistake. 8 is here, and the 4 is here. Okay, so again, for the same statement of alternate interior angle, when I draw a line that is parallel to PFQ, line M, those angles in between 5 are also the same as 4 and 8. So 5 is actually the result of 4 plus 8. So this statement is also true. Since we know that our right statement are statement number 1 and statement number 3, I know that my right answer is answer C. Let's start talking about triangles. And here is where things start being more interesting. There are many types of triangle that we can run into. Equilateral triangle is the characteristic of having all the angles the same, and so all the sides are the same. The angles here are going to be always 60. The side, the measurement of the side can change. The isosceles triangle is a triangle that has two exactly the same side. They are the one that connect with the base. Then they are the one that also connect with the top. Also, the other characteristic is that also the two angles at the base are going to be the same. For this reason, we have some theorem that we need to learn about the isosceles. Another type of triangle that we can run into is the scalene triangle. Now, the scalene triangle is the characteristic to have no sides that are the same, and so no angles are the same. But there is a very particular scalene triangles that is very interesting for us, which is the right triangle. The right triangle is a scalene triangle that has one angle that is 90 degrees. And that will allow us to find main information, which we will see soon. Let's talk about these things about triangles. The first thing that you already know is that the sum of the angle of the internal angle of the triangle are 180 degrees. I don't know if you know, but if we draw an extension of the base side of a triangle and we form this exterior angle, the result of this exterior angle will be equal to the sum of the other opposite remote interior angles. So A plus B will make the angle exterior angle C. Now, what I want to talk to you is about these two theorems. Very important. The first isosceles triangle theorem says that if you have a triangle, and you know that this triangle, the two legs here are the same, you automatically know that also these base angles are going to be the same. And the true is also the opposite, meaning if you know that the two angles A and C are the same, you automatically know that the two legs must be the same. Another important theorem is the corollary theorem, the isosceles triangle theorem corollary, which is that basically if we bisect our isosceles, and remember bisect meaning that we cut it perfectly in half, now we have created two right triangles. In fact, this angle right here is going to be 90 degrees. And these two triangles, ABD and CBD, are going to be the same. Now that we start talking about right triangle, we need to start talking about two important information. In fact, when you deal with the right triangle, you can solve those triangles just in two methods, and they are very useful, both of them. One is by using Pythagoras theorem. I hope you remember Pythagoras theorem, but if you don't remember, the Pythagoras theorem says that the square built on the hypotenuse is equal to the sum of the square built on the two cadets. So the square built on C is equal to the sum of the square built on A to the square built on B. From this, we have this formula. And we will use this formula a lot. We can use this formula to find just C, which will be just C equal square root of A to the power of 2 plus B to the power of 2. But we can use also to find A, which is this one on the side, one on the smaller side, which would be just C to the power of 2 minus B to the power of 2. The same for B. C to the power of 2 minus A to the power of 2. Those are all formula coming from this theorem, okay? But then with right triangles, we can use spatial right triangle. Now, what is a spatial right triangle? Spatial right triangles are ratios regarding measurement of the side of the triangles. Since the angles of triangles never change, for equilateral triangle, we always gonna have 60, 60, 60 triangle. Also, some other triangles, also some other angles will never change. And this specific one that we are interested in to use a spatial right triangle are those right triangle that have angle 30, 60, 90, or 45, 45, 90. If we have a triangle with that measurement, we can find the measurement of all the sides by using this ratio. Let's take a look at it. For example, we have this problem. This problem says, in the figure above, if AD is equal to BD and is 2 square root of 3, what is the length of AB? So our goal is to find this length. Now, I can tell you right away that there is not only one way to solve this problem, but I'm gonna use only one right now, where I'm gonna show you both methods, Pythagoras and spatial right triangle. So let's analyze it first, the figure, okay? Because this figure has many good things. The first thing is that we know that this side is equal to this side. And since these two sides are the same, that means that the triangle ADB is an isosceles triangle. And that means that since this side is equal to this side, this angle must be equal to this angle. Another information that I know is that this angle is 90 degrees, right? Since this angle is 90 degrees, I know that this angle is 60. And the reason why I know that this angle is 60 degrees is because since the triangle ADB has two angles that are 30 degrees and 30 degrees, to reach 180 degrees, this angle right here must be 120. And since this angle ADB and this angle ADC are supplementary angles because the total will be 180, what is left was 60. Since that one is 60 and since this one is 90, this one must be, the angle at A must be also 30 degrees. So you see, we just found all the angles of this figure. Find them all, isn't it? Now we need to understand how to find AB. How can we find AB? The method to find AB is to consider the entire triangle ACB, which is a right triangle. And we know that to find AB, which would be the hypotenuse, we need to use the Pythagoras theorem. And the Pythagorean theorem tells us that we need to find that by doing AC to the power of 2 plus CB to the power of 2. Do we have AC? Do we have CB? No, we don't have any of them. So we need to find them. To find them, we could use the special right triangle, this one right here. Let's take it and let's bring it here. The special right triangle can help us to find the rest of the information, all the rest of the side. Why? Because if we take in consideration the triangle of the figure ACD, that one is a right triangle, right? And is a triangle 30, 60, 90. Like this one right here. Let me flip this one so you can see it better. We have the same angles here. This is 90, this is 60, and this is 30. Of this triangle ACD, I know the measurement of AD is going to be 2 square root 3. And I know also this hypotenuse from this special right triangle, that one will be 2x. This one will be x, and this one will be just x square root of 3. That means that I can put this, that is a ratio, equal to this one, and I could make a proportion. So I could say 2 square root of 3 is equal to 2x. This one allows me to find x, and my x will be just square root of 3. But what it means that? That means that CD, since is corresponding to this side, is just going to be equal to square root of 3. As well as AC is going to be equal to square root of 3, then multiply square root of 3, which is just 3. So now, thanks to the fact that we use special right triangle, we know from this main triangle that CD is going to be square root of 3. And AC is going to be 3. So now we have for sure this. Do we have CB? We do have CB because CB is going to be the sum of CD plus DB. So AB will be equal to the square root of AC, which is going to be 3 to the power of 2, plus CB, which is 2 square root of 3 plus square root of 3, which is 3 square root of 3. Now we can find the measurement of AB, which will be 9 plus 9 that multiply 3. So it would be 9 by 3, 27, plus 9, 36, which is that AB is going to be equal to square root of 36, which is 6. I hope it is clear. If you don't have it clear, ask me during the lesson. And now I want to talk about similarity postulate. When we talk about special right triangle, like in this case, basically we are talking about similarity postulate. The similarity postulate is telling us that two triangles are said to be congruent if two angles are said to be congruent, meaning they have the same measurement, then the two triangles that we are referring to must be similar. that means that all the angles are going to be the same, because if the two angles that are similar are congruent, also this angle must be congruent, because it's still just 180 degrees, the sum of them. And what's different is just the measurement of the side, but we can use ratios and proportions to be able to find any information that we're missing. So for example, let's do this problem. Let's start from scratch. This problem is asking, in the diagram below, ABC is similar to DEF. So this triangle is similar to this triangle. What is the value of y minus x? So y and x are the measurement of these two sides that we don't have. But what we know is that the angles are the same. So the ratio of their side, the corresponding side, must be the same. That means that I can write something like AB over ED, which is the ratio of these two sides, must be equal to BC over EF. Isn't it true? It is. This one can be rewritten with the actual value. We know that AB is equal to 9, and we know that ED is equal to 3. This one must be equal to BC, which is the value that we are looking for, over EF, which is 5. That means that if I do cross multiplication, besides, I don't need to do cross multiplication. This one will become just 3. So I'll just multiply both sides by 5. X will be equal to 15. We can do the same proceeding to find my value for y. I can say that df is equal to AC as I can use again AB over the only thing is that now I need to flip it, ED over AB, right? So let's put the value here, and it would be df is what we're looking for, meaning y over AC we know to be 21. That needs to be equal to ED over AB. ED is 3, AB is 9. That one would be just 1 over 3. That means that when I isolate my y, I will do 21 over 3. 21 over 3 would be just equal 7. Now the question is asking, what's y minus b? Y is 7. Y minus x. Y is 7. X is 15. 7 minus 15 is equal to -8. So my answer would be just A. Now, I left here this little figure for a specific reason, which I'm gonna tell you later. Honestly, right now it's too early. We're gonna talk about that when we talk about trigonometry. But that's how we use the similarity postulate. When you know the two triangles are similar, we can use proportion to find information of the triangle of the other triangle that we don't know. This case, as you can see, is about a triangle that is neither a rectangle or isosceles, just a scalene triangle. So we can use the postulate for any type of triangle. We can use the right triangles when we do the right triangles, because that one is already a ratio well made, prepared with the x value that can give us the information that we're looking for. This is about similarity of triangles. We already went over. It's just a repetition of some data. What I want to talk about is area of triangles. The main formula, the formula that is also provided to you, is the formula about any triangle. There is 1/2 base by height. For right triangle, the formula is basically the same. Just remember that your base and your height are going to be always the legs, never the hypotenuse. And then there is the equilateral triangle formula. In case you don't have the height, you can use this formula. Honestly, the only formula that I really think you need to remember is the basic one and know how to apply it. In this figure, for example, the question is asking, what is the area of the triangle ABC? Now, we have a couple of problems for finding the area here. Since the area is 1/2 base by height, what we're missing here is the base and the height. The base, it will be the side AC, and the height will be BD. How can we find those two information? Special triangle. I'm supposing that I can use a special triangle. Why I'm supposing that? Well, I know that this angle is 90 degrees. I already see that these are two 30-degree angle. So I know that these two angles are going to be 60 and 60. I already see that this one is an isosceles. This is split. So I already assume that my left and my right side are going to be the same, but also the value that I have already can give me that information. So again, I can use special right triangle to find the information that I want. Why? Because I can take just the 30, 60, 90 special right triangle, and I can compare it with one side. Let's say I compare it with the side A, B, D. So I know now that my hypotenuse is 12, and the comparison will be with 2x. That means that my value for x will be 12 divided by 2, which is 6. So that means now that one of my side, in this case, will be BD, is equal to what? Just to x, which is 6. And now I know that AD will be equal to 6 square root of 3. That means that AC, which is just equal to AD plus DC, and AD plus DC are the same for the corollary theorem regarding the isosceles theorem, then I know that this one will be equal to 12 square root of 3. So now I know all the information to find the area, because that one will be 1/2 of AC, which I know to be 12 square root of 3, then multiply BD, which is 6. 12 by 6 divided by 2, my area will be 36 square root of 3. Here we have a problem that is basically the same as this one, just the information are provided differently. The question say, in the figure above, what is the area of the isosceles triangles ABC? Here, they're not giving us nothing beside the fact that BC is 26, AC is 48, and this is an isosceles triangle. To find the area, we are missing a key value, which is the height. However, since this one is an isosceles, when I split the figure with a bisect, which correspondent to the area, called this point D. I know that these two angles are 90 degrees, right? And what's gonna be the dimension of AD, which is gonna be equal to DC? Alpha 48, which is 24. Here, I don't know the measurement of the angle, but I know that that one is a right triangle, so I can use Pythagoras theorem to find BD. Because to find BD, what I have to do is just the hypotenuse, 26 to the power 2, minus one of the smaller side, which is 24 to the power 2, right? BD then will be 26 to the power 2 minus 24 to the power 2. BD will be equal to 10. Now that I have BD, I can just find the area, because the area will be the area of the triangle ABC will be 1/2 of base, which we already have it, is 48, multiplied by 10. So 48 multiplied by 10 is 480. 480 divided by 2 is going to be 240. That's my area. I hope this video clarified everything about triangles, but also angles and lines. If you have any question, ask me. Exam is coming, so that's the time to ask. Okay? I'll see you in the next video. I'll see you in the next class. Bye.